Good day, class. You are welcome to our chemistry online class for this week. Today we'll be discussing acid-base titration. We'll be taking the theory part of this class, while when we have the opportunity to meet, we together look at the practical parts. We'll be taking the practical part of this lesson. The practical part of this lesson is as important as the theory part of this lesson. Please, I want us to be serious with this lesson. At the end of this lesson, I want us to be able to describe materials which are used during acid-base titration. I also want us to be able to state the precautions and care which must be adhered to achieve accurate results during titration. Also, I want us to be able to solve questions based on acid-base titration. What is titration? Titration is the method employed during volumetric analysis. It involves adding a solution from a granulated vessel to a second solution in a flask until the chemical reaction between both solutions comes to completion. And you can only know when the reaction has come to completion by the color change, which is as a result of indicator which is present in one of the solutions. Hello, I repeat again. You can only know when the reaction comes to completion as a result of color change of the indicator that has been added to one of the solutions. Take note of that. In any titration, the simple ideology is this. A standard solution is used to standardize a solution which is not standard. What is a standard solution? A standard solution is a solution which concentration is known. Why? Unstandard solution is that solution which concentration is not known. So during volumetric analysis, a standard solution is used to standardize a solution which concentration is not known. And while carrying out titration, like I said, you can only notice or have the idea that the reaction has come to completion as a result of color change of an indicator that has been added precisely to one of the solution. Now, in an acid-base titration, the indicator is usually added to the base, and when the color of this indicator change, it comes to our knowledge that the reaction has come to completion. So therefore, what is an indicator? Indicator are weak organic acid or base that changes color based on the level of hydrogen ion concentration present in a solution. The choice of indicator which is used during titration depends on the strength of the base and acid that is being titrated together. The table below shows or gives us examples of certain indicators and their color change in different medium. Litmus paper in an acid is red, in a base is blue, at the end point of a reaction is always purple, and is best suited when you are titrating a strong acid and a strong base. Meteorage in an acid is pink, in an alkali is yellow. At the end point of a reaction, it is orange and is suitable for titrating a strong base and a strong acid, and a weak base. Meteorate, on the other hand, in an acid is red, an alkali is yellow. At the end point of a reaction, it is orange and is suitable for titrating strong acid and a strong base. Lastly, phenolphthalein in an acid is colorless, in a base is pink. At the end point of a reaction, it is colorless and it is suitable when you are titrating a weak acid and a strong base. Take note, for a weak acid and a weak base, there is no suitable indicator. Definition of terminologies. Concentration. Concentration can either be defined in moles per dm cube or in gram per dm cube. Thus, concentration of a solution is defined as the amount of a solute dissolved in 1 dm cube or 1000 cm cube of that solution. Like I said, it can be expressed as mole per dm cube or can be expressed as gram per dm cube. Mathematically, concentration in moles per dm cube or in gram per dm cube is defined as amounts divided by 1 dm cube or 1000 cm cube of solution. Thus, we can say that concentration is the same as amount of substance all over volume of substance, all over volume of solution. Amount of substance all over volume of solution. Now, molar concentration, on the other hand, is the concentration of a solution in mole per dm cube. Take note, molar concentration is the concentration of a solution in moles per dm cube, while molar solution is a solution which contains 1 mole or the molar mass of a compound in dm cube. Materials used during acid-base titration. They include the pipette, the burette, the Brito stamp, the filter paper, the funnel, the conical flask, the beaker, the standard volumetric flask, the weighing bottle, the chemical balance. Even in the absence of filter paper, we can also use white tie. Like I said, when we resume, we'll be carrying out the practical aspects of this lesson. Now, what are the care for some of these materials? The burette. Ensure that in an acid-base titration, we usually put acid in the burette. So, before you use your burette, make sure you rinse with distilled water and allow the water to drain off from the burette. Now, if you are in too hurry to allow the water to drain off, then you can rinse the burette with your acid. This enable foreign materials in the burette to be dissolved and removed so that it does not affect your reading at the end of the practical class. Number 2, make sure that the burette, the jet of the burette is filled. Make sure that the jet of the burette is filled. Number 3, avoid blowing air through your burette. And lastly, when you are taking reading, ensure that your eye level is on the same as the meniscus of the burette to avoid error due to parallax. Now, for the case of the pipettes, in an acid-base titration, we usually use the pipettes to draw sample of the base. Now, while we are using that, ensure that you rinse your pipette with the base. Also, it's enabled to dissolve or remove any foreign materials inside the base so that it does not affect your reading. And also, don't blow air through your pipette. Don't blow air through your pipette. And when you are trying to get out the last drop of alkali base inside the burette, please don't blow air through it. For the conical flask, rinse only with distilled water. You don't have to rinse with base, neither do you have to rinse with an acid. You only rinse with distilled water. And also, after every titration, rinse with distilled water before you carry out another experiment. Please, let's take note of this. It is very, very, very important. Calculations in volumetry analysis. Recall we said during volumetry analysis, a standard solution is titrated against a standard solution. Now, when you compare the mole ratio of these two solutions by saying amount of A divided by amount of B, if we recollect very well, I said concentration is amount all over volume. That means that amounts can be defined as concentration times volume. So therefore, the amount of A is concentration of A times volume of A, while the amount of B is concentration of B times volume of B. Now, hence, when we input this into amount of A all over amount of B to form the mole ratio, then we have the CAVA all over CBVB, which is equals to the amount of A divided by the amount of B. Ca, concentration of acid in mole per dm cube. Cb, concentration of base in moles per dm cube. Va, volume of acid. Vb, volume of base. Na is the number of mole of acid as seen in the balanced chemical equation of the reaction, and likewise Nb is the number of mole of base as seen in the balanced chemical equation of the reaction. Example, for example, if you are given 0.05 moles of an acid titrated against a solution of a base, which is sodium triazocarbonate 4, and if 37.5 cm cube of the acid is used to neutralize 25 cm cube of the base, we are asked to calculate or deduce the concentration of the base in mole per dm cube, or the concentration of the base in gram per dm cube. Now, from the equation of the reaction, we found out that 1 mole of tetrasulfate 6 acid is reacting with 1 mole of sodium triazocarbonate 4. Therefore, concentration of B in moles per dm cube from stoichiometry, CAVA all over CBVB is equal to NA/NB. From the information in the equation, our Ca is equals to 0.05 mole per dm cube, our Va is 37.5 cm cube, our Vb is 25.0 cm cube, while our Na from the equation of the reaction is 1, and that of the base is also 1 to 1 of tetrasulfate 6 acid to 1 of sodium triazocarbonate 4. Therefore, now if we input the values in the formula, CAVA all over CBVB is equals to NA/NB, and make CB the subject of the formula, we can deduce that the concentration of the base in mole per dm cube is equal to 0.075 moles per dm cube. For the concentration of the base in gram per dm cube, we call concentration in amount of moles is equals to mass all over molar mass. Therefore, we can say concentration, we can say that numbers of mole is equals to concentration in gram per dm cube all over molar mass in gram per mole. Then, making concentration in gram per dm cube subject of the formula, we can deduce that concentration in gram per dm cube is equals to numbers of moles, which is amounts times molar mass. That is, the molar mass of sodium triazocarbonate 4 is 106. 0.075 times 106. Therefore, concentration of B in gram per dm cube is 7.95 gram per dm cube. Assignment. I've never been getting feedback from this particular class as regard my assignment. Please, I'm begging us. This is the only way we can interact this period because of the lockdown. Please, let's take this assignment serious. That is the only way I know you are following the class. That's the only way I know I am not teaching in vain. Please try to always do your assignment and submit to my WhatsApp number 08034187864. In the first question, you are having 0.24 mole per dm cube of an acid titrated against sodium hydroxide base, and you are given at 21.5 cm cube of the acid neutralized 25 cm cube of the base. You have to calculate the concentration of the base in mole per dm cube and also the concentration of the base in gram per dm cube. In the second question, you are given that 2.4 gram per dm cube of A is reacted with Y hydroxide solution. Now, and we are told that 21.5 cm cube of the acid neutralized 25 cm cube of the base. Now, you have to deduce the concentration of that base in mole per dm cube. Now, that base is not completely known, so you are having it as Y hydroxide. So, therefore, you have to determine the atomic mass of Y. Then, if you can determine the atomic mass of Y, then you will know which element is Y. At the end of the day, From there, you have to calculate the concentration of B in gram per DNP. Please, we will see in the next class. Let's try to stay safe. Thank you and God bless.